Now let's talk about accuracy and precision. Most likely you never thought about the differences between the two. Probably you use them interchangeably. However, in science, both mean two different things, although related. What is accuracy? Accuracy is the degree of agreement between the actual and the measured value. What's the actual and what's the measured? Well, let's look at this game of bullseye and let's look at the part C. In part C, what could we classify as the actual value? Well, let's say that the center of the bullseye is the actual value that we are trying to obtain by throwing the darts at it and hitting the center yellow part. But your value, which represents the measured value, falls outside that place. This is what we mean by being inaccurate. If I say that I have a pill of aspirin that weighs 1.23 grams, I know that mass and I ask you to use the balance to measure the mass. And the actual mass is 1.23 gram. However, the measured mass that you measure and you do 3 trials, you get 1.00 grams, 1.50 gram, and 1.25 grams. Each time you are not accurate, although in the last case when you got 1.25 grams, you are pretty close. So that's the measure of accuracy. Accuracy is the degree of agreement between the actual and the measure value. We represent accuracy by calculating something called percent error, which we will do in the next lab on density and volume in week 3. The error is the difference between the true value and our estimation, and the error could be random or systematic. What's the difference? Random error means that your values are showing up in every direction around the actual value. If my darts are hitting in all the directions, then I'm making random error all the time. However, if all my darts are hitting in one particular direction, let's say where I'm moving the cursor here in this direction, then I'm probably having some kind of systematic error in my work. So that is accuracy and percent error. We'll learn how to calculate percent error later in the lab. Now, precision, on the other hand, is a measure of the agreement between the replicate measurements. What does that mean? For precision, look at part B here. Clearly, we are not hitting the center of the bullseye, which means we are not accurate. But look where we are hitting. And while we are not accurate, all of our darts are bunched close together. We are precisely hitting this one spot. We have very good precision. We say we are inaccurate but precise. And so what does that mean if you were to do science? Well, if the measure, once again going to back to that mass of that aspirin tablet, if it's 1.23 grams, what if you get 1.50 gram, then 1.51 gram, and then again 1.50 gram? All three of your measurements in all three trials are very precise. There is some error, and that error is most likely systematic error, either human error or instrumental error, that's causing you to not be accurate but be very precise. We measure our precision by calculating something known as deviation, which is the amount of variation present in a set of replicate measurements. Wherever we do science, we want to be precise and accurate. So here is this example where we are hitting the center and each time we are precise. Could we be precise but not accurate? Yes, we see here. Could we be imprecise and inaccurate? Yes. And could we also be accurate without being precise? That's very hard to explain. But think about bullseye where you are hitting once here, then here, then here, then here, and then in the center. If you had to average all of your darts, the average would be considered to be right in the center, but you would be so imprecise each time because the distance between each of them is very high. So that's the measure of accuracy and precision.